Just 2 minutes more, please. Oops, اسكت. Good afternoon, everyone. Do you hear
Good
me?
afternoon.
Good afternoon, Professor.
How are you?
Well,
Good. Okay. Next class, July 24th, we will have quiz 2. Quiz 2 will cover parts 7 and 8. 7 and 8. Just 7 and 8. Okay, today we'll talk about computer architecture and processors. So our objectives, we'll talk about computer architecture, machine language, program execution, arithmetic logic instructions, communicating with other devices, and other architectures. So in computer architecture, we have central processing unit, CPU, or processor. Is also called processor. It has arithmetic logic unit, control unit, registers, and we have mainly two kinds of registers, general purpose and special purpose. We'll talk about each one of them. Bus and motherboard. So if we look at here, we can see here's the central processing unit or CPU. So we have arithmetic or logic unit. Arithmetic unit do multiplication, addition, and so on. Logic doing logic operations and so on. Control unit and the register unit. And we can see the bus here connect the CPU with the main memory. Stored program concept. A program can be encoded as bit pattern and stored in the main memory. From there, the CPU can extract the instructions and execute them. And we will see how this happens. Machine instruction is the instruction or the command encoded as a bit pattern recognized by the CPU. Machine language is the set of all instructions recognized by the machine. Machine means here computer, of course. Different instructions like data transfer, copy data from one location to another. Arithmetic logic use existing bit patterns to compute a new bit pattern. Control, which directs the execution of the program. So here we can see the CPU, like more details here, has program counter and instruction register. And the regular registers. The CPU connected with the main memory through a bus. We can see here the address, memory address for each cell. And as we see, the address is given in hexadecimal symbols. So each symbol represents 4 bits. So we have 2 symbols for each cell, means we have 8 bits. Okay. The parts of the machine instruction has mainly two parts. Any machine instruction has two parts, opcode and operand. From the opcode, we can determine which operation we need to execute, what kind of operation we need to do. Operand gives us details about the operation. We'll see this in different examples. So interpretation of operand varies depending on the opcode, based on the operation, the type of operation we need to execute. So the composition of an instruction for the machine, as we see here, opcode, the first part, we mentioned two parts, opcode, operand, and this is the operand. So the total number of bits for the instruction is 16 bits. 16 bits. 4 bits for the opcode and the rest for the operand. These bits represented in hexadecimal symbols. And we know each hexadecimal symbol represented by 4 bits. So we have 4 hexadecimal symbols to represent the instruction. This example for one of the instructions, 35A7. So what this means? What these numbers means? 3 means store. This instruction means store. So the first symbol is opcode. It gives us kind of operation we need to do. So store the contents of register 5. Now we have the details about the instruction, the operation. Store the contents of register 5 in the memory cell at the address A7. This is the mean or the translation or the decoding of this instruction. 3 means store. So store the contents of register 5 in the memory cell with address A7. So these are different instructions, and the encoded version is here, or translation. So 156C, 1 means load. There is appendix for these instructions or for operands. So 1 means load. 5 means add. 3 means store. C00 hold or stop. So 156C means load register 5. Load register 5 with the bit pattern found in the memory cell at 6C. At the address 6C. 166D load again. Similar instruction. Load register 6 with the bit pattern found in memory cell at address 6D. 5056 means add the contents of register 5 and register 6, the contents of register 5 and the contents of register 6, they were 2's complement representation. The contents are in the form of 2's complement, and leave, so add them and leave the result in register 0, or store the result in register 0. 306E means store the contents of register 0 in the memory cell at address 6E. And C00 means home. Any questions so far? Any question? Program execution controlled by 2 special purpose registers. Program counter. In program counter, we can see the address of the next instruction. Instruction register. In instruction register, we can see the current instruction. The machine cycle has 3 phases. Phase 1, fetch. 2, decode. 3, execute.
Sorry, I don't understand.
So fetch, phase 1 fetch, or retrieve the next instruction from the memory as indicated by the program counter. And we'll see this. And then increment the program counter by what? Based on what we mentioned so far. After we retrieve the instruction, as soon as we retrieve the instruction, the next instruction, the program counter will be incremented
by 2.
by 2. Why 2?
Because there are 2 more steps. Decode and execute.
Yeah, by 2. By 2. Why by 2?
Because after fetch, you have decode and execute. So that's, you're doing 2 more steps. Sorry. Or is it not?
Okay. What's your code?
7?
Chin?
Yeah.
Okay. Anyone else has answer for that? Why not by 4? Why not by 1? Why 2? Okay, let us go back here. Just to remind you with what we mentioned here. What we mentioned here. The instruction, how many bits in the instruction? How many bits?
2 bits.
The instruction.
Four bits?
How many bits? Man.
Oh, 16.
16.
16, yeah.
16 bits.
Yeah.
16 bits, right? So means 8 and 16 bits. 8 and 8. Each cell, 8 bits. Each cell, each memory cell, has only 8 bits, and the instruction 16 bits. This means for one instruction, how many cells we need?
2 cells.
2 cells, right? So one instruction is stored in 2 cells, like the first instruction, stored in cell with address 00 and address 10. So when we retrieve the first instruction, means we retrieve the instructions or the bits in the 2 cells. So this means, like, say, start with A00, start with 00. So what is the next instruction we retrieve? What is the next address?
20.
We already start with 00. So what is the next one? The next instruction start with address what?
20.
02.
02.
Perfect. Right. What's your code say? What's your code? The one who says 02.
7.
7.
And there is someone else too.
Who else?
It was 18. 18.
18. Okay, Travis, thank you. Yeah, because when we retrieve the first instruction, actually we retrieve like 00 and 10. So the next one will be 02. And then the next one after that 04. So that's why we incremented by 2. The program counter incremented by 2. We'll see this in example. Then the next phase, decode, means decode the bit pattern in the instruction. Then execute, perform the action required by the instruction in the instruction register. So this is the 3 phases of the machine cycle: retrieve or fetch, decode, execute, or perform. So let us do example. So the program stored in the main memory ready for execution. So here the program stored in the memory, in the main memory, as you see here. Start with address A0. So we can see here in the program counter, we see the address of the instruction which we need to retrieve. Program counter contains the address of the first instruction, A0. Okay, so when we retrieve the instruction, after we retrieve the instruction, what we can read here? What we can read here? We
15.
read this. We read this, right? Because A0 is 15, A1 6C. So 156C. We retrieve the contents of the 2 cells, the first 2 cells. At the beginning of the fetch step or retrieve, the instruction starting at address A0. So the instruction at A0 is 15 or 51, sorry. And C sets, what I just read it to write it, to type it here right. So 156C is retrieved from memory and placed in the instruction register here. Okay. So we retrieved this one. As soon as we retrieve the first instruction, which has two cells. What happens here? This changes to what?
A2.
A2, perfect. Thank you. What's your code, sir?
7.
7. There is no 4, there is no 12, there is no, just a 7. Just a 7 and the 3 and the 2 and 18, 30, 31.
Mm-hmm.
Okay, we almost done, guys, and still people not participate, unfortunately. So this will be immediately we after we retrieve this the first instruction, we read here A2. As soon as we carry this instruction, what we can read here after we carry this instruction? What we read here?
We're loading.
Hmm?
We're loading 5 with 6C.
What is that?
Oh, you were saying, what does it read as? 1 is load, right?
When this instruction carried out, what is the new one we can see here?
Oh, the one after that we're going to fetch is going to be 166D.
Perfect, thank you. What's your code, sir?
18.
80, as I mentioned, you know? Okay, thank you. Love, thank you. Exactly. After, as
No
soon as we carry out the instruction here, we retrieve the next one, which has address A2, because we mentioned we have A2 here. So again, we retrieve two cells. The instruction in the next two cells. So this is still not carried out yet, but the next one will be 166D. Okay. As soon as we retrieve 166D, what happens here? What we read here?
A2.
Man, A2 is here. It's okay, let us go back here.
Oh, I didn't realize you meant next. A4.
A4, exactly. What's your code, sir?
30.
30. Thank you. A4. And as soon as we carried out 166D, what is the next instruction we should have?
50, 56.
Exactly. 50, 56. Thank you. What's your code?
30 again.
30 again. Thank you. This is the most important part in this section. Everyone see what I'm saying, or you need me to go back and go through this again? It's clear for everyone. We have short class today. Okay, so if you have any question, just ask, please. Any question? Okay. Arithmetic or logic operation, like we mentioned, logic as mentioned before, logic operations and or exclusive or arithmetic like add, subtract, multiply, divide. Communicating with other devices, controller, an intermediate component that handles the communication between the computer and other devices, like between the computer and a device. There are specialized controllers for each type of device, and there are general purpose controllers, which called USB. A port is defined as the point at which a device connects to a computer. It's called port. We don't have lab today. We'll work on the project actually after that. Yeah, we'll work on the projects. We finish the labs. Some people ask me on the chat, so I answer them. Starting next class, we'll work on the project using Kurtz. So everyone, please, by the way, everyone should be download Kurtz 2, based on the instruction I mentioned. So the port is the point at which a device connects to a computer, or also called interface, actually. It's also called interface. Port or interface. It's called also interface. Okay. So we can see here is connection between the CPU and the main memory through bus. So between the modem and the computer connected to the modem through controller, connected to monitor through controller, and as you see, each device connected to the computer through a controller. Von Neumann bottleneck. What is this? Insufficient bus speed impedes performance. Like if the capacity is not sufficient, if the bandwidth is not sufficient, so this affect on performance. Handshaking is the process of coordinating the transfer of data between components. As we mentioned before, we have parallel communication, which means several communication paths used to transfer bits simultaneously, like parallel lines. Serial communication, as we mentioned, bit by bit, is transferred. So we have single line. We mentioned here we have advantage for parallel. It is, who remembers the advantage for parallel communication? The advantage of using parallel communication. What is the advantage?
It's faster.
Faster, perfect. And what's the disadvantage?
There's a higher chance of errors.
Not zeros. What's the code verse?
30.
Faster is good, but what about the disadvantage?
The coupling effects, the
What?
magnetic fields,
What's the
interfere.
code? What's the
7.
code? 7. Yes, coupling, or we mentioned crosstalk. Crosstalk, because we have multiple lines close relatively to each other. So couple and each line, of course, there is current path because bits transferred. So signal transferred. So we have current. So coupling happens between the lines, and this cause interference or which we call it crosstalk. Perfect. Serial communication bit by bit. What is the advantage of serial communication?
There's no crosstalk.
No crosstalk. And the disadvantage?
Slower.
Slower. What's your quote?
30.
Thank you. Okay. Kilobit per second, bit per second is use this notation. Kilobit per second, 1000 bit per second, megabit 10 to the power 6, gigabit 10 to the power 9, as you see. And the bandwidth refers to maximum available rate or data rate. Data rate. Other architectures, technologies to increase throughput or increasing the number of instructions that can be processed and reducing the delay between completed instructions. This can happen using parallel processing, in which we use multiple processors simultaneously. Any questions? Any questions? We should take quiz 2 today, actually, but I wished to give you more chance to review because this will help for the final also. So please review parts 7 and 8. And next time we'll as I mentioned, we'll talk about the project and the Curtis too. We have more than enough time to do that, so it's okay. And a portion will take for the quiz. So portion for talking about the project and the other portion for the quiz. Any question? We done for today. Any questions?
Is the project going to be like a group project like the
Yes.
labs are, or is it going to be one?
Yes,
Okay.
group submission. Group submission.
Okay,
Sir?
thanks.
It will be two parts actually. A part using VHDL and the other part using schematic. So we'll do both of them together. But yes, it is group submission. Bahava, wait, please, after we finish. Wait. Bahava, do you hear me? Bahav? Okay, guys, thank you. Have a good day. If you don't
Professor,
have... Yes.
sorry for interrupting. I was just wondering, when are we getting our lab 2 grades back?
Lab 2?
Yeah,
Very soon.
thank you.
Who's it? Who's speaking?
Chen.
Chin. Okay. Yeah, very soon. Inshallah.
Okay, thank you.
Mm-hmm.
Thank you, Professor. Have a good day.
You too. Take care.